So we get to start a new unit today. We are in Unit 6, yay! Algebra 1, Summit Lakes Middle School. So we're going to be starting Unit 6, so hopefully you have your packets out and ready to go. Talk to me if you need to know more about it. Of course, the electronic copy is also out on Schoology, so you can access all of these pages electronically also. So let's go through our first lesson today, Systems of Equations by Graphing. So, two or more, so let's just go through these notes. This is just kind of an introduction to the whole unit. Two or more linear equations together form a system of linear equations. There are three ways to solve a system of linear equations. Today we will focus on solving by graphing. And we're going to use slope and y-intercept. It's a piece of cake, especially after the unit on graphing. This won't be any problem. We're just going to graph using slope and y-intercept. Nothing too difficult. You will graph both lines and find where the lines intersect. This point of intersection is the solution to the system. This solution will also be written as an ordered pair. Well, it makes sense, doesn't it? Because if two lines intersect, they're going to intersect in a point. Okay, that point of intersection, that point has to be an ordered pair. And that's going to be the solution. So not like the inequalities we were just talking about. But this is going to be in exactly one point. You can check your answer by plugging the ordered pair back into both equations to see if it is true. So it can't just be true for one or the other. It has to be true for both. Okay, so here we go. We're going to solve by graphing. We're going to solve y equals x plus 5. What's my y-intercept? 5. Good. So 1, 2, 3, 4, 5. And my slope, what is that number there? That's 1. So my slope is 1 over 1. So I'm going to go up 1 and over 1 and down to the left and over to the left. Now this is one time where you definitely want to have your straight edge. So get out that student ID or something else to use for a straight edge. I, of course, am going to use my handy-dandy straight edge that AAA sent me because they were so nice. They sent me 2 free gifts. So there's our first line. And it's really important that we're going to have a straight edge, no matter what your straight edge is, so that then we can really see where they intersect. Let's graph the other one. Okay, so on the second equation, what is my y-intercept? It's 0, that's right. So we're going to start at 0, 0. Now my slope is negative 4, so it's 4 over 1. So I'm going to go down 1, 2, 3, 4, and over 1. And up 1, 2, 3, 4, and over 1. Oh, special treat. They actually, by using slope, we found out where they intersected, which is kind of a trick you can use too. So, where did they intersect? This point right here. This point right here. What is that point? Find the point of intersection. Okay, we did that. The lines intersect at the point, what is that? Negative 1, 4. So, negative 1, 4 is a solution. Okay, so wherever they intersect, that was the solution. And you saw this on the NWEA test. Wherever you had systems of different things, wherever they intersect, that is the solution. You'll see this on the ACT. You'll see this on the end of course exams. You see systems everywhere. Okay, so now we're going to check. And remember, in order to check our answer, we have to see if it works in both of them. So we're going to take the point negative 1, 4, plug it into both equations. So first I'm going to start off with y is equal to x plus 5. Oops, that's my blue one. So I plug in 4 for y, negative 1 plus 5. So I get 4 is equal to 4. Ta-da! That one works. Let's see if it works on the other one. So we have y is equal to negative 4x. So 4 is equal to negative 4 times negative 1. I'm just plugging in my x value, my y value. I get 4 is equal to 4. Ta-da! It works. We are right. Yay us. Okay? So now you're going to try this one. You're going to graph these two lines, find out where they intersect. Go. So just checking in. I'm sure you got that first line all graphed in, no problem. Look at this one, though. We can't graph it just as it is. Remember what we have to do here. We have to get it in slope-intercept form, meaning we have to get y by itself. Okay, so we're going to add 12x to both sides. And again, if you're getting this, pause your video at any time and just go ahead and finish it on your own. Divide through by 4, and I get y is equal to 3x minus 1. Okay, now we're going to plot that point. That part you can do on your own. Go. Now, when you plotted them, this is the reason having a straight edge is so important. You have to find out where they intersect. This is where they intersect. Now you can always kind of check yourself to make sure your graphing is correct. So go back to my original and I go up 2 over 1. On this one, I can go back to one of my points and go up 3 over 1 and see where they intersect. So this would be my solution. That is the point 2, 5. And you can check yourself by plugging it back in. So this is my answer. That is my solution. It's where the two lines intersect. I can then plug it back into both of these equations and find out if it's true. Let's do that. Go. And when you plugged them in, you found out that, yes, they did both work. They were both true for both of them. Okay, let's go to the back side of this sheet. Whoops. Solve by graphing. Let's do this one again. So here we go. You're going to graph each of these lines. Ready, set, go. So notice what happened when you graph these lines. Where did they intersect? They didn't, okay? So is there a point of intersection? No, there's not. Okay? So what did you graph? Well, remember what these are called. These are parallel lines. Okay, parallel lines will never intersect. So is there an intersection point? No, because they're parallel. They'll never intersect. Therefore, this system has no solution. They will never intersect. Now, we could have also told that by looking at our original problem. Notice what happened with both of these. You might have already figured this out. Look at that slope. The slope on both of these are the same. So how can we tell this without graphing? If the slope is the same. Same slope. Now, this doesn't make sense until we do the next one, but the other thing that will make a difference is look at my y-intercepts. Are my y-intercepts the same? No. Different y-intercept. Okay, so let's go to the next one. We're going to graph the next one. Keep in mind of that second equation, you have to get it in slope-intercept form. Okay, go. So if you haven't noticed already, it's like, hold on a second, didn't I just graph that line? Yes, you did. When you graph it again, you're going to get that same line, right? You see that? The blue dots right there, that's this one. The orange is this one. That's the orange line. So they're the same line. So what did we graph? We graphed the same line. Okay? Is there a point of intersection? There sure is. It is all over the place. Yes. All the points. They have all the same points, so they intersect infinitely many times. Therefore, this solution has infinitely many solutions. How can we tell this without graphing? Okay, well look, once we get them into slope-intercept form, okay, need to be in slope-intercept form. Once we have them in slope-intercept form, they're going to have the same slope and the same y-intercept. In other words, they're going to be the same line. Once you get them into slope-intercept form. So this is crucial. You have to get them into the same one. Now this just kind of tells you very quickly what's happening. So if we have a different slope and if we have a different y-intercept, we're going to have one solution. And these are the three different choices you can have when you're talking about systems. You can have one solution, you can have no solution, or you can have infinitely many solutions. Those are the three options. If they intersect, it's going to be one line. They're going to have different slopes and different y-intercepts. Okay? Here they're going to have the same slope, but different y-intercepts. Okay? And here they have everything the same because they are the exact same line. So those are going to be your option. Parallel, same line, and then they intersect just once. Okay? They will eventually intersect. So let's look at your homework. The first question is just determine if this is a solution. So all they're doing is here's the solution. So basically what you're doing is you're checking to see if it works. Then you're just going to graph on the same one. On all of these, you're just going to be graphing. Good. Now this one, tell whether each system has one solution, no solution, or infinitely many. Look back at your notes. Okay, look back at your notes and notice what it says. They need to both be in slope-intercept form in order to compare their slopes and their y-intercept. Okay, so this is what you're going to be doing for homework for solving by graphing. Great. Oh, it also says to explain. So tell me if it's going to be one, many, or none, and then tell why. And you can just say exactly what we talked about over here. Same or different slopes. Okay, good. If you have questions, you know where to find us.